Okay, so this morning I'm just going to briefly go through Lecture 7, some practical considerations that we need to take into account. Just a hint here, these generally make for good theory questions to add into exams and tests. The drawings, I think we discussed that in class quite well. So that sample drawing that I put onto the Moodle site, download it, have a look at it. Just bear in mind that that's some pretty basic information that we put on this drawing. Once this has gone to the contractor, he will send it off to his pre-stressing subcontractor, and then they provide a very detailed shop drawing based on the information you give them. Probably one of the most important things is that you get the pre-stressing notes right, and any stressing sequence or any other notes that you put into the drawing. As for the actual, I'm just going to show you here quickly. As for the shape of the cable profile, if you refer back to Lecture 5, we discussed the calculation of ordinates of a parabola. So you would be able to calculate the offsets from the soffit, and they will base their design on that, and they will give you a shop drawing based on the ordinates that you give them, and you'll get the profile correct. Right, as far as practical considerations go, just refer to your notes for this particular lecture. Remember now, in most cases, we design for free bearings at the ends. Remember that in practice, your pre-stressed element can act as you assumed in the design. Just make sure of that. If you designed a simply supported beam, ensure that it's built as such and it's not fixed at one of the ends, or either end or both ends are fixed. It must be simply supported, it must be resting on bearings that allow it to rotate and allow it to move. So when you apply your pre-stress, that elastic deformation is allowed to take place. Otherwise you're restraining something in the system and it's not going to work the way that you designed it. Very important, lateral stability of your structure. Make sure that your beam isn't going to fall over. When it's in its final position, while you're working on it, while you're applying the pre-stress, make sure it's propped. Before you lift it into place, make sure that it's propped correctly. Once you place it, make sure that as soon as you place it and before you release the slings from the cranes, that it is properly and laterally supported and propped. Make sure that it cannot fall over. Then point number 3, when we're designing our precast beams and we might need to lift them into position, just make sure that your beam isn't overly heavy, for one, and the cranes can't do it. Make sure that you've got space for your cranes to do this before you design it to be lifted. And make sure that your beams are lifted from the correct points on the beam section. I think we'll talk about that a little bit in a minute. Okay, so basically what I'm saying here is that don't go and design yourself a nice big heavy beam if they can't fit cranes in to place it. Right, moving your precast beams. If you did build a precast beam on a site, instead of building it in situ, quite often you don't have to move it very far to get it to its final position. But quite often the little roadway to get there is quite rough. So make sure that your beam, when it's being transported, usually on a horse and dolly system, when it's being transported, make sure that it doesn't twist the beam too severely. In fact, it shouldn't twist it at all. The one in this particular example that we see here in this photo, the beam was slung upwards so that as the horse and dolly rotated separately from one another, the beam still hung in a vertical position. So make sure that that can happen. You don't twist your beam. Make sure that your roadway is well compacted so that your dolly doesn't sink and your beam doesn't fall over. Then point number 5, make sure that your lifting positions are suited to your design. Very important. Usually your beam is designed to be resting at the ends, and then if they lift with a crane from a point too far in from the end, remember that you're changing your bending moment. Your dead load bending moment is changing completely by doing that. Be very careful of doing that. So you must lift as close to the ends as possible, as close to your bearing positions as possible. Okay, method of lifting, also very important, just something to bear in mind. Often tensile loop bars are used as lifting points from the top of the beam, and this is probably, in my opinion, one of the worst possible ways to lift a beam because of the brittle nature of a high tensile steel bar. If a beam is small enough and light enough, then I would say lift it with a mild steel cast and hook. That's fine. But for heavy beams, such as the one in this example, I'd rather have holes formed through the flanges, where you can see there, and then lift with a lifting bar through the web. Much better position, a much better system to lift with. Another alternative is to be able to fit a sling right underneath the beam and lift it from the underside. Okay, one or two safety issues we need to just talk about. Until such time as the post-tensioned cables are fully grouted into position, they must be treated with extreme caution. A sudden release of tension through failure of a wedge or a weak point in a strand is analogous to flicking a rubber band, but on a far, far greater scale. Very dangerous. Don't ever stand immediately adjacent to a jack while stressing, and never behind the jack. Never use damaged strand, never reuse strand. Small indentations in the strand are left behind from where the wedges have bitten into the steel, and that causes a weakness in the steel, so never reuse the strand. Make sure your concrete is correctly specified, especially in the end blocks. Make sure that they put the concrete in properly, they're placed properly, and that they compact really well. Very easy for honeycombing to form around an anchor. Come to stress it, and then that happens. The anchor, the concrete has failed because of honeycombing behind the anchor, and it has burst out of the side of the beam. Also, very dangerous. One last thing just to be aware of is the hydraulic pipelines that connect the jack to the pump. These are under immense pressure, so inspect them for damage before use and ensure they don't get damaged or walked on during use. Quite a good idea is to actually lay rubber matting over the top of the hydraulic cables or hydraulic pipelines, so that if one does burst, it's retained underneath the rubber matting. Okay, an important practical thing to do on site at the time of stressing is to keep an accurate record of the tensioning operation. The jacking force in the tendon and the extensions at the back of the jack, as the cables are basically being stretched out the back of the jack, that extension must be measured at regular intervals and plotted on a load extension graph, very similar to the diagram I've shown here, this example that I've seen here. The plotted points on this graph right up to the full pressure in the jack, implying that your full force in the cable had been applied, should make up a nice straight line that is extrapolated all the way down to the horizontal axis over here, and the interpolated reading to the left of the vertical, the gauge pressure axis, the vertical axis, accounts for the slack that was pulled up in the tendons before the stressing was applied. Your total measured force, your total measured extension is then compared with theoretical extension, and you can use this as an integrity check to make sure that the correct force has been applied into the cable and the cable is extended by the full amount. Okay, an example of what could happen. Basically, you've applied the full pressure in the jack, but you've only measured half the extension that you would have expected. Okay, this is indicative that there's a possibility that the cable has jammed somewhere in the duct. The cable is jammed possibly because of a damaged duct during the concreting process. A grout has got in and it's seized up, and the cables, only half the cables are being stressed if you're getting half the extension. That implies that the jam in the cable has happened halfway along if you're getting half the extension. If you're only getting a third of the extension, then about a third of the way away from where you're jacking, you should find that the thing is jammed up there. Or maybe there's a bit of grout leakage into the duct and it's bound up the cables. A very dangerous situation that might have arised there because the closer the cables have become grouted up to the actual jack, the more chance you've got of actually breaking them. So very, very, very careful of that. An experienced pre-stressing subcontractor would have realized that he's off the track as he's stressing. He knows theoretically, compared with his practical results, he knows what he should have received, and he would have stopped the operation if he was way off track. Okay, I'm going to leave this there. So this is lecture 7. It's just a brief overview of some practical things to bear in mind. Read through the notes and keep them close at hand during the exams, because this is a good place for questions to come from. I'm going to put this up on the website, and I'm also going to go on and do 1 or 2 more lectures shortly. Okay.